On this one, graphing tangent and cotangent. And then tomorrow we'll look at secant and cosecant, and that will wrap up all of the different graphs that we need to look at. For tangent and cotangent, we're going to start on your handout where I put the table on there. The table is a little bit different. I put different values than I did on sine and cosine, and once we draw the graph, you'll understand why I picked what I did. For talking about tangent, let's just start at 0. Tangent of 0 is 0. Pi over 4 is like 45 degrees. Tangent of 45 is 1. Pi over 2 is 90. Tangent of 90. Undefined. 3 pi over 4 is quadrant 2. Tangent is negative in quadrant 2. Reference angle pi over 4, so you get negative 4. You need to think about pi. Y over x, 0 over negative 1 is 0. Instead of going all the way to 2 pi, I did negative angles instead. Negative pi over 4 just means you spun down. So we're in quadrant 4. Tangent is negative in quadrant 4. Tangent of 45 is 1, so negative 1. Negative pi over 2 would be here. Tangent y over x, negative 1 over 0 is undefined. Negative 3 pi over 4 is quadrant 3. Quadrant 3 tangent is positive. Tangent of pi over 4 is 1. Negative pi is the same as positive pi, and so we get 0. So on my graph, I am going to label the tick marks I put with my pi, like negative pi over 2, 0, pi over 2, and pi. Then the halfway marks are going to represent my pi over 4s. So at negative pi, tangent is 0. At negative 3 pi over 4, it's negative 1. At negative pi over 2, it's undefined. That means we have a vertical asymptote there. We talked about asymptotes in algebra. The line we're getting close to, but not actually touching. Whoops. I said 1, and I plotted that point at negative 1, didn't I? At negative 3 pi over 4, the point was 1. At negative pi over 4, we're at negative 1, 0, 0, pi over 4, 1. 3 pi over 2 is again undefined. 3 pi over 4 is negative 1. And pi is 0. If we plotted more points, we would see this is a curve. Asymptotes are lines that you're getting close to, so you need to make sure that your curve is approaching your asymptote. And so our graph looks like this. All right. Obviously, the graph doesn't just stop here just because I did. You could keep going. It's just going to keep repeating itself. But if you notice, if I just took this middle section of my graph, I have one complete period of tangent right here. Sorry, I feel like I'm going to sneeze. Excuse me. If I go on to this point, I'm repeating things we've already done. So our first period has passed. So unlike sine and cosine, tangent has a different period. It starts repeating itself after a length of pi. I prefer, instead of just graphing my graph from 0 to pi, I like to go from negative pi over 2 to positive pi over 2. Because if I pick that particular interval, then my asymptotes are at the end and I just have one complete curve in the middle. If you chose to graph it from negative pi, or from 0 to pi, you would have to put an asymptote in the middle, and that tends to just be a little more confusing for people. So we are going to pick a little different interval for tangent than we did with the others. My domain, if I'm talking about my x here, it exists everywhere except where we have these asymptotes. So for my domain, I'm just going to say x cannot equal, and I'm just going to list some of the values, so I'm going to say dot, dot, dot. My next asymptote would happen at negative 3 pi over 2. We had one at negative pi over 2, positive pi over 2, positive 3 pi over 2, dot, 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 that would keep going. So it's those odd multiples of pi over 2, 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. You're going to have a vertical asymptote every time. My range, if I'm talking about my possible y values, that curve keeps going up and down forever, so what is my range? Negative and positive. Is this graph even or odd? Remember, even meant symmetric to the y-axis, odd was symmetric to the origin. Odd. So this is odd, just like sine was. What that means is that if you have a tangent of a negative angle, you can pull the negative out in front. So remember, cosine was even. If it had a negative, we can just drop it. Tangent and sine so far are odd. If they have a negative angle, we pull that out in the very front. Question 6. Let's graph cotangent. Let's not do the complete table. Let's just go from 0 to pi on this one. So at 0, cotangent of 0. So tangent of 0 is 0, so cotangent would be undefined. Pi over 4, 45 degrees. Tangent is 1, so cotangent is pi over 2, or 90 degrees. Tangent is undefined, so cotangent would be 0. 3 pi over 4, you're in quadrant 2. Cotangent of 45 is 1, so you get negative 1. At pi, remember if you're looking at your last table, tangent of pi is 0, so that means cotangent is undefined. So let's label these points. At 0, my graph was undefined. At pi, my graph was undefined. Those are vertical asymptotes. Pi over 4, we had 1. Pi over 2 is 0. 3 pi over 4 is negative 1. This is a curve. It is approaching the asymptote. So it looks like this. So just like tangent, it has a period of pi. That's how long it takes to begin repeating itself. The difference is tangent, we went from negative pi over 2 to positive pi over 2, and the graph was increasing. Cotangent, we're just going from 0 to pi, and our graph is decreasing. My domain, where do I have my vertical asymptotes this time? Yeah, at the pi. So x cannot equal, I'm going to put dot, 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 and just list some of them. 0, pi, next one would be at 2 pi, 3 pi, and so on. It's all the pi's. What's my range? If I kept going with my graph, pattern continues over here. Is this one even or odd? It's not the exact same, but it is the opposite. So this is again odd. So once again, we're seeing if you have a cotangent of a negative angle, you can pull the negative out in front. So these are the tangent and cotangent graphs. Keep this handout in front of you so we can reference it as we go on. Now we are just going to start graphing these functions. We're going to go through the same list of information that we were doing with sine and cosine. We're just going to have a little bit different process to think about. So if I said to graph y equals tangent 2/3 x, amplitude. I'm still referring to my amplitude as a number out in front, so that would just be 1. My period. With sine and cosine, we did 2 pi divided by the coefficient of x, because 2 pi was how long it took for the normal sine and cosine to repeat themselves. What is the normal period for tangent and cotangent? Pi. So for my period, I will do pi divided by the number in front of x. So we get 3 pi over 2. Count by is the same, your period divided by 4 quadrants. So we get 3 pi over 8. With sine and cosine, we talked about, sometimes you needed to do the interval, sometimes you didn't. I'm just going to recommend, why don't we just always do the interval in tangent and cotangent? You don't necessarily have to, but because we have weird starting and stopping points, it usually helps people. So I'm just going to go ahead and try that. With tangent, where did I tell you we would typically start and stop our graph? That was cotangent. Negative pi over 2 to positive pi over 2. So I'm going to say negative pi over 2 is less than or equal to 2/3 x is less than or equal to positive pi over 2. So now I'm going to divide by 2/3, so you can think of it as multiplying by 3 over 2. So I get negative 3 pi less than or equal to x. No, sorry, negative 3 pi over 4 is less than or equal to x is less than or equal to 3 pi over 4. So I'm starting at negative 3 pi over 4. Add your count 5. We need 5 total points. So plus 3 pi over 8 will be negative 3 pi over 8. Plus 3 pi over 8 is 0. Plus 3 pi over 8 would be 3 pi over 8. Plus 3 pi over 8 would be 6 pi over 8 or 3 pi over 4, which is where we said it should end. My amplitude is 1, so I'm putting points at positive 1 and negative 1. The reason I picked this interval for tangent is because then we know that at the ends, both ends are going to be vertical asymptotes. The middle point will be where you're at 0. And then tangent was increasing. So at negative 3 pi over 8, we're going to be at our negative amplitude, and then we'll be at our positive amplitude. And so our graph looks like this. So you have to remember which way the graph is going. Is it increasing or decreasing? And you have to remember tangent goes from negative pi over 2 to positive pi over 2. Cotangent goes from 0 to pi. Any questions on it? I'm just going to keep practicing. So I have negative 1/2 tangent 2x. What's my amplitude? 1/2. What's the negative do? Period. Normal period for tangent is pi divided by the number in front of x, so it's pi over 2. Count by is period divided by 4, which is pi over 8. Let's go ahead and do the interval. Where do we typically start and stop tangent? So negative pi over 2, less than or equal to 2x, less than or equal to positive pi over 2. If we divide by 2 or multiply 1/2, we get negative pi over 4, less than or equal to x is less than or equal to positive pi over 4. Negative pi over 4 is my first point. Plus pi over 8 would be negative pi over 8. Plus pi over 8 is 0. Plus pi over 8 is positive pi over 8. Plus pi over 8 would be pi over 4. We pick this so that we can put asymptotes at both ends and 0 in the middle. Then tangent is increasing. So at the negative pi over 8, you should be at your negative 1/2. And positive pi over 8 is at positive 1/2. And then drawing the curve. Oh, yeah. I wrote flip, but I didn't do that. Thank you. Okay, so that means at negative pi over 8, I'd be at the positive 1/2. At pi over 8, I'd be at the negative. Here we go. So far, so good? We'll do a few more, make sure we've got it. Say I gave you 3 cotangent of 1/2 x. Amplitude, 3. Period, pi over 1/2 is 2 pi. Count by, period divided by 4 is pi over 2. Interval. Where does cotangent typically start and stop? 0 to pi. Divide everything by 1/2 or multiply by 2. And we get 0 to 2 pi. So my first point's at 0. Plus pi over 2 is pi over 2. Plus pi over 2 is pi. Plus pi over 2 would be 3 pi over 2. And plus pi over 2 would be 2 pi. The amplitude is 3. Just like with tangent, we pick this interval so that we have asymptotes on both ends. and a 0 in the middle. Now, cotangent, is it increasing or decreasing? Decreasing. If you think about it, this is like in the first quadrant, everything's positive, so it has to be positive right here. So at pi over 2, you'd be at your amplitude, which is 3. 3 pi over 2, your extra negative amplitude, negative. How do you guys feel about this? So, are you okay with it? Nobody answers, I'm going to assume that means yes. Let's do a harder one and see how we feel. Throw everything in here. I want 2 periods of y equals 3 plus the cotangent of x plus pi over 2. Amplitude. 1. Period. Pi. Count by. Okay. Interval. It's cotangent, so we're going to put it between 0 and pi. X plus pi over 2. If I solve for x, I subtract my pi over 2. So we get from negative pi over 2 to positive pi over 2. What's this 3 doing to my graph? 3. I asked for 2 periods. I'm going to do 1 first. We're starting at negative pi over 2. Counting by pi over 4. So negative pi over 2 plus pi over 4 is negative pi over 2. Plus pi over 4 is 0. Plus pi over 4 is pi over 4. Plus pi over 4 is pi over 2. This graph is going up 3. So just like we did with sine and cosine, we're going to go to positive 3 and draw a dashed line to help us. We pick this interval because then we have asymptotes at both ends. And 0 in the middle. But my 0 point will actually happen at positive 3 because we moved up. Okay, does cotangent start high or low? High. Amplitude was 1, so I will start 1 above this. So we'll start at 4, hit our 0, and then we go 1 below. We didn't flip or anything, so it just looks like that. How do I get my second period? Add 4 more points. Keep adding our pi over 4. So that's 3 pi over 4, pi, 5 pi over 4, and 6 pi over 4, which would be 3 pi over 2. And continue the pattern. Asymptotes at the ends. Your 0 at the middle. Starts high and goes low. do we need more of these? So what I want to do then, you've got about 18 minutes, I want to give you time to start this. That way you can ask for help if you need it. First 4 or first 6 are matching, and then there's your graph.